So, you already know by now that 3I-ATLAS has officially zoomed past Mars and is now rapidly speeding toward the Sun. This is actually the most intense phase of its interstellar road trip as we all know it. It's blasting out water way farther from the Sun than it should, and its coma is packed with carbon dioxide like it's trying to win most atypical comet of the year. Clearly, this visitor didn't come from around here. With perihelion already at hand, astronomers have their telescopes locked on it, waiting to see what continues to happen as sunlight and radiation crank up the heat. So, what I'll try to do in today's video is I'll try to explain these new findings and explain why they actually matter and what this wild space traveler might do next. The thing is, this whole saga of 3I-ATLAS kicked off in July 2025 when astronomers in Hawaii, using the ATLAS survey, spotted a tiny object moving way too fast to be gravitationally grounded. One look at its hyperbolic orbit, and we confirmed our third interstellar visitor after the cosmic celebrities Oumuamua in 2017 and 2A Borisov in 2019. Fast forward to early October. It slipped across the orbital lane of Mars, and Europe's ExoMars trace gas orbiter snapped a distant glamour shot. No tail in sight, just a bright compact coma, hinting that this comet doesn't follow the typical grow a tail and sparkle script. On the other hand, ground-based telescopes and the James Webb Space Telescope teamed up for a spectroscopic deep dive. They found 3I-ATLAS puffing out water vapor like a space humidifier on overdrive about 40 kilograms per second, while still 2.9 astronomical units from the Sun. That's way too much enthusiasm way too soon. And the carbon dioxide to water ratio, that too, was completely flipped compared to most comets we know. Instead of water taking charge like in most comets, 3I-ATLAS seems to be powered by carbon dioxide. Basically the soda fizz comet of the cosmos. Polarimetric observations back that up too, showing that its dust scatters light in a way that suggests either super fine grains or just plain weird chemistry. And get this, old data from the Transiting Exoplanet Survey satellite shows it was already active 6 astronomical units from the Sun. That's so far out that most comets are still in hibernation mode, refusing to acknowledge the Sun even exists. This kind of early activity is extremely rare. It tells us that 3I-ATLAS formed in a place much colder and more chemically unusual than our local neighborhood. A completely different stellar system with its own rules, its own vibes, and apparently its own recipe for comet juice. And that makes scientists very excited and maybe a little confused. Typically, water ice doesn't start sublimating until a comet gets closer than 3 astronomical units. That's why most comets snooze until they reach the inner solar system. But 3I-ATLAS, nope. It decided to wake up early and start causing problems. The top theories so far, super volatile chemicals like carbon dioxide or carbon monoxide are lurking just beneath the surface. So sensitive to heat that even the gentle warmth of deep space was enough to make them pop. That pressure may have cracked the crust, letting gas and eventually water escape long before schedule. Another possibility, its nucleus might be a crumbly mess, porous or fractured enough that sunlight can sneak deeper inside and heat things up faster. No matter the explanation, one thing is clear. 3I-ATLAS is giving us a rare peek at what comets are made of in other solar systems. And it's wildly different from what we're used to seeing around here. A carbon dioxide-dominated comet like 3I-ATLAS signals one big thing. This traveler was born way out in the deep freeze suburbs of a distant protoplanetary disk, not the warmer coffee drinking region where our own comets typically form. Its interstellar trajectory backs this up, making it the cosmic equivalent of a tourist with a very foreign passport. Even its polarization, the fancy term for how its dust scatters polarized light, refuses to match patterns seen in local comets. That means its dust grains could be structured differently, sized differently, or even made of minerals we barely see around here. And since dust grains basically carry chemical selfies of their home systems, scientists might actually be able to piece together what kind of environment shaped it. Yes, there are always the bold, maybe it's aliens theories. Shout out to Avi Loeb. But in this case, everything points to a totally natural origin. Just a highly volatile, chemically unique snowball forged around a far-off star. Sorry sci-fi fans for now. With Oumuamua and 2I Borisov already in the Hall of Fame, 3IATLAS is only the third confirmed interstellar visitor, making these objects rare VIP guests at the solar system party. Each one helps us learn how planets and comets form throughout the galaxy, not just in our tiny neighborhood. Now, the real suspense. On October 29th, 3IATLAS swings in for its closest solar encounter at 0.53 astronomical units. That's the hot seat moment, literally. Astronomers are prepping their popcorn because three outcomes are on the table. 1. Massive outburst. It suddenly throws a flashy cosmic tantrum and grows a dramatic tail. 2. Breakup. It cracks apart like a cookie that got too warm. 3. Smooth survival. It casually strolls past the sun like it's no big deal. Least likely. But hey, comets love surprises. Whatever happens after perihelion will be crucial. That's when we'll grab the best data and hopefully the juiciest secrets of this interstellar intruder. JUICE, the European spacecraft, not your breakfast beverage, is currently hanging out on the far side of the sun, perfectly placed to watch what happens after it swings around perihelion. The only catch, it'll be using its backup, slower antenna, so the science updates will arrive fashionably late, sometime in early 2026. Spacecraft have communication issues, too, apparently. Back here at home, the James Webb Space Telescope, Hubble, and a whole army of ground-based telescopes will be watching the show in something close to real time, tracking every change in the coma, every chemical shift in the spectrum, and every dramatic outburst if 3IATLAS decides to throw one. If it makes it through its fiery, close pass with the sun, it should reappear in our skies in early December, gliding past Earth at a comfortable distance of 270 million kilometers. No need to panic. That's basically across town on a galactic map. This comeback gives researchers a perfect before and after comparison. How does solar heat transform material that formed around a totally different star? That's the kind of experiment you cannot run in a lab, even the fancy ones. And the stakes are bigger than this single visitor. With 3IATLAS joining Oumuamua and 2I Borisov on the interstellar scoreboard, we're starting to piece together how debris travels between star systems and how planetary formation might differ throughout the galaxy. These cosmic hitchhikers may carry clues about how worlds are born, evolve, and sometimes fling their leftovers our way. Plus, every interstellar detection helps scientists improve their early warning systems. That means the next time a mysterious object dives into our solar system, we'll be ready to grab our telescopes faster. Every time one of these interstellar visitors swoops through our neighborhood, we learn a little more about how many of them are out there, what they're made of, and how they react when the sun cranks up the heat. As our detection technology keeps improving, we might soon be ready to study future cosmic travelers up close. Maybe even send a dedicated spacecraft to chase one down for a proper meet and greet. 3IATLAS stands out from every comet we've ever seen. From its oddball chemistry to its way too early activity. It's like a walking, or rather flying clue from another star system entirely. And its upcoming moment at perihelion isn't just a dramatic plot point. The results could change how we investigate interstellar objects for years to come.